In the last lecture, we did certain formulae which was important with respect to numerical questions which come in your exams. One very important formula which we did in the last lecture was that of density. कि एक crystal की density को हम कैसे calculate करते हैं. The density of the crystal that is equal to Z into M upon A cube into N naught, where Z, that is the number of constituent particles which are present in any unit cell. M is the molar mass or the atomic mass of the constituent particles. A cube, A is the edge length. So A cube हम लोग volume ले रहे हैं of the crystal, and N naught, that is going to be the Avogadro's number. Based upon this formula, we are going to discuss certain questions in today's class. So let's go on to the first one. Your question is going to come on this side. The question is, at room temperature, sodium crystallizes in body-centered cubic lattice with A is equal to 4.24 Angstrom. Calculate the theoretical density of sodium. So this is a very easy question. We will apply the formula direct. The formula is D is equal to Z into M upon A cube into N naught. So Z over here, it is a body-centered cubic lattice. We had discussed that for body-centered cubic lattice, Z becomes equal to 2. And then we take the atomic mass of sodium. The atomic mass of sodium is 23. The edge length given is 4.24 Angstrom. This has to be converted into centimeter. So 4.24 into 10 raised to power minus 8 cube. 1 Angstrom is equal to 10 raised to power minus 10 meters. So 1 Angstrom will be equal to 10 raised to power minus 8 centimeters into Avogadro's number. (6.02 to 10 raised to power 23). Right? So when you calculate this, the density comes to 1.002 per gram, 1.002 gram per centimeter cube. Right? So this is the first easy question. This kind of question is very important from your examination point of view, and for the past many years it has seen that one numerical comes from this section. ठीक है? So एक और question, अभी मैं इस वाली क्लास में 4 questions आपके साथ डिस्कस करूंगी, और फिर आपको questions इसमें डेंसिटी पे और बहुत सारे जो है theoretical questions they have been given to you in your assignment. So next question हमारा, let's see what the question is. Next question जो है, that is silver crystallizes in a face-centered cubic unit cell. The density of silver is 10.5 grams per centimeter cube. Calculate the edge length of the unit cell. So in this question, आपको edge length calculate करनी है. वही formula हम apply करेंगे. Density is equal to Z into M upon A cube into Avogadro's number. ठीक है? अब silver crystallizes in face centered. So face centered में Z will be equal to 4, और Ag का जो mass होता है, atomic mass 108, A cube हमें calculate करना है into 6.02 into 10 raised to power 23, और डेंसिटी हमको दे रखी है कितनी क्वेश्चन में 10.5. So A cube will be equal to 4 into 10 raised to power 23. A cube जब हम कैलकुलेट करते हैं तो A cube हमारा आ रहा है 68.3 into 10 raised to power minus 24. So A क्या आ जाएगा? that will be the cube root of this 68.3 into 10 raised to power minus 24 का cube root, right? अब जो 10 raised to power minus 24 है उसको हम 3 से डिवाइड करेंगे तो वो कितना आ जाता है 10 raised to power minus 8. 68 का हमें cube root कैलकुलेट करना है, so you can do it. 4 4s are 16. 16 4s are 64, so the answer should come to 4 point something, and the answer is coming as 4.09 into 10 raised to power minus 8. Now ये वाला आंसर जो हमारा आ रहा है, this answer is coming in centimeters. Okay, so अगर हम इसको एंगस्ट्रॉम में कन्वर्ट करें तो it will become equal to 4.09 Armstrong. ठीक है? So this is the second type of question in which you have to calculate the edge length. Okay? फिर उसके बाद हमने एक फॉर्मूला और करा था in which we were finding the nearest neighbor distance and the radius. So let's do a few questions on that formula also. But before that, let's take a recap of the formula which we had done. क्या था? एक टेबल सा हमने किया था for simple cubic. The nearest neighbor distance D, that is equal to A, and R is equal to A by 2, right? The second one was FCC, face centered cubic, in which the distance was given as A by under root of 2 and radius was given as A by 2 under root of 2. Okay, and the third one is body centered cubic, BCC, in which the distance is given as under root of 3 by 2 into A, and R is given as under root of 3 by 4 into A. Okay, so on the basis of this, we will do our first question. First question. The question is, ammonium chloride crystallizes in a body-centered cubic lattice with a unit distance of 387 picometers. Calculate A, the distance between oppositely charged ions in the lattice, and B, the radius of NH4 positive ion if the radius of Cl negative ion is 181 picometer. So this is your question. Now in body centered, the arrangement is in body centered cubic lattice. So if you remember, in body centered cubic lattice, the ions are present in cross diagonal. Right? So अगर बॉडी सेंटर्ड में सारे कॉर्नर्स में प्रेजेंट है तो एक जो है दैट इज प्रेजेंट एट द क्रॉस डायगोनल, इसको हम क्रॉस डायगोनल बुलाते हैं. सो फर्स्ट पार्ट में हमको क्या कैलकुलेट करना है? हमें कैलकुलेट करना है डिस्टेंस बिटवीन द नियरेस्ट नेबर्स. सो डिस्टेंस बिटवीन द नियरेस्ट नेबर इज गोइंग टू बी दिस, और फॉर बीसीसी D is equal to under root of 3 by 2 into A. अब under root of 3 कितना होता है? That is equal to 1.732. और A हमको कितना दिया है? A given to us is 387 into 387 divided by 2. After solving, we get 335.15. 335 0.15. Now this is the nearest neighbor distance between two ions. Okay. Second, what are they asking? They are asking us the radius of the cation. So radius of the anion given to you is, this is part A, B. Radius of the cation given to us in the question is 181 picometers. So what will be the radius of the anion? 335, which is the nearest neighbor distance. 335.15 minus 181 picometers. ठीक है? So इसका जो आंसर आएगा, इसको कैलकुलेट करके 154.15 picometers. This is going to be the answer. Right? So this is how we do such kind of questions. Let's discuss one more of the same kind. The question is, a unit cell cube length for LiCl, lithium chloride, having NaCl structure is 5.14 angstrom. Assuming anion contact, calculate the ionic radius for chloride ion. Okay, अब यहाँ पे जो हमारे पास है, that is NaCl structure, and NaCl structure, rock salt structure, which we have already done, that is FCC structure. तो FCC structure के लिए हमें calculate क्या करना है? हमें calculate करना है radius. So radius that is going to be equal to what? For FCC, A by 2√2. ठीक है? अब A हमें दिया है 5.14 angstrom upon 2 into value of √2 is 1.414. तो हम इसे अगर कैलकुलेट करते हैं तो this comes to 1.87. 1.87 angstrom. There is an alternate way also to do this, in which we take FCC structure, if you remember. In this, the nearest neighbor is present in the cube diagonal. ठीक है? Diagonal, cube diagonal पे present रहता है, so it is present over here. This is touching this and this is touching this. Okay? So we have taken this triangle. This and this. Right? Now chloride ions, they are present over here and over here. Okay, so let's see what is the distance. Distance over here between lithium and lithium, that is given to us as how much? Total distance is given 5.14. So the distance that is going to be the distance between this, that will be distance between lithium and chloride ion is 5.14 divided by 2, this comes to 2.57. So this means that this is 2.57 and this is also 2.57. This is Cl negative, this is Cl negative. So according to Pythagoras theorem, what is going to be the distance between two chloride ions? Distance between two chloride ions, D will be equal to √ of 2.57 का square plus 2.57 का square. Okay? So ये complete √ हमने लेना है. इसको कैलकुलेट जब हम करते हैं, then it comes to 3.63 angstrom. It comes to 3.63 angstrom. So what is going to be the radius? Radius of Cl negative, that is going to be equal to 3.63 divided by 2. 3.63 divided by 2, which is 1.82 angstrom. Clear? So the answer is almost coming to the same. So these are a few questions. Then we go on to our next topic today, packing efficiency. Right? There are some questions in your assignment which you need to discuss, and if you have any problem, you can get back to me. Okay? Alright. So the next topic which we are going to do today, that is packing efficiency or packing fraction. What is packing efficiency? Packing efficiency means that how much of the space is occupied in a crystal lattice. How much of the space is occupied in a crystal lattice, that is known as the packing efficiency or the packing fraction of a crystal. So it is defined as the ratio of volumes occupied by atoms in a unit cell to the total volume of the unit cell. So if we are mathematically doing it, packing efficiency, that is going to be equal to volume of the constituent particles of the unit cell upon volume of the crystal or volume of the unit cell. Because we are taking unit cell, so in denominator also, instead of crystal, we can take the unit cell, volume of the unit cell, right? So we will discuss all three types of crystals, cubic crystals. The first one, that is known as simple cubic. In simple cubic, the constituent particles is going to be 1. Constituent particles is going to be 1. So volume of the constant particles of the unit cell, we assume कि जो constituent particles हैं वो sphere है, और sphere का जो volume होता है वो 4/3 pi r cube हो गया. अब अगर 1 ही sphere present है unit cell में, तो numerator हमारा क्या आ जाता है? Volume of the constituent particle. So constituent particle की volume को मैं VCP लिख रही हूँ. That is equal to how much? Volume of the constant particles 1 into 4/3 pi r cube. ठीक है? और volume of the unit cell UC, that is equal to A cube. We have to convert this A in terms of R. So simple cubic का R क्या होता है? That is equal to A/2. 2R is equal to A. अब यहाँ पे हमको A cube लेना है. So A cube will be equal to 2R का cube is equal to 2 2s are 4, 4 2s are 8. 8R cube. Right? So let's put in the formula. We have packing efficiency, volume of Cp of the unit cell. Constant particle की volume कितनी आ रही है? 4/3. So we have 4/3 pi r cube, और इसकी कितनी आ रही है? So the fraction is coming as pi/6, which is equal to pi is equal to 3.14. 3.14 divided by 6, और इसे कैलकुलेट करके हमें आता है 0.52. दिस इज द पैकिंग फ्रैक्शन. और 52% of the spaces in simple cubic are occupied. तो empty spaces कितनी हो जाएगी? 100 minus 52. So it means 52% occupied and 48% empty spaces are present. 48% empty spaces are present. So second we have face-centered cubic structure. Let's now calculate volume of constituent particles. Face-centered cubic structure में unit cell में 4 constituent particles होते हैं. So volume of constituent particles will be 4 into 4 by 3 pi r cube. Volume of the unit cell, that is equal to a cube. ठीक है. सो अगर a क्यूब आ गया तो इन टर्म्स ऑफ r हमें कैलकुलेट करना पड़ेगा. फॉर फेस सेंटर r इज इक्वल टू a बाय 2√2. सो a वुड बी इक्वल टू 2√2 into r, that is equal to a, and a cube will be equal to cube root of 2 into under root of 2 r का क्यूब. तो ये कितना आ जाता है? 2 2 4 2 8, 8 2 16, 16 under root of 2 r का क्यूब. Right? So let's put in the values now. ये भी इधर इसको भी थोड़ा सा हम कैलकुलेट कर लेते हैं. 4 into 4, that is 16 by 3 pi r cube. Now the packing efficiency is what? Volume of the constituent particles of a unit cell. So volume of constituent particles is 16 by 3 pi r cube. by 3 pi r cube, or volume of the unit cell is 16 under root 2 r cube. Right? So ये हमारा कट गया, r क्यूब और r क्यूब भी कट गया. So हमारे पास क्या आ जाता है? 3.14 upon 3 into under root of 2. When you calculate this comes to 0.74, which means 74% of the space is occupied. If 74% is occupied, तो empty कितनी हो जाएगी? 26% of the space is empty. Right? Okay. Then the last kind of cubic structure which we have, that is body-centered cubic. So let's calculate the packing efficiency for body-centered cubic. BCC structure, body-centered cubic. In body-centered cubic, the number of constituent particles present in the unit cell are 2. So we have body-centered cubic में, let's calculate the volume of constituent particles, which is equal to 2 into 4 by 3 pi r cube is equal to 8 by 3 pi r cube. This is the volume of the constituent particles. Then volume of the unit cell, a cube, right? For body center, the relation is r is equal to under root of 3 by 4 into A. Okay, so what is A? 4R upon under root of 3, that is A. So what is going to be A cube over here? 4 4s are 16, 16 4s are 64, R cube upon 3 under root 3. Clear? So let's calculate the packing efficiency. What is the volume of the constant particles? 8 by 3 pi R cube. The volume of the unit cell is 64 R cube 3 under root 3. So what is left over here? Pi and root of 3 by 8. And when we calculate this for body centered, it comes to 0.68. 0.68, right? So this is 0.68 means 68% is occupied. And how much is empty? 100 minus 68. 32% is empty. Right? So for today we will only do till here. Please solve the questions which would be given to you in the assignment.